Hello class, this is Mr. Reynolds, and we want to look at some more ways of representing some molecular compounds. Okay, you already know how to do Bohr models. You have to give some more of those to me, some Lewis structures, you'll do those, and we're going to teach you how to do these overlapping electron configurations. You know the electron configuration part, or you've worked with those some before, and now we're just going to overlap those. Okay, different styles show some they can show some things better than other styles can. Um, okay, moving on with it. The first thing we'll look, I'm always going to give you the chemical formula, like H2O, and I'll give you its structural formula. Okay, notice how the hydrogens are angled down. That's what it looks like. Okay, the arrangement of the atoms is structural form. You're going to give me three things. Okay, you're going to give me the Bohr model representation of this. And let's do that. We've got 8 protons and 8 neutrons for hydrogen, 2 electrons on the first shell, 6 on the second shell. And we spread them out because they don't like each other. Looking back at the structural formula, we can see these hydrogens are angled down some. So we're going to bond them onto these, onto sharing with this electron right here. Remember, we want to share electrons. Plus 1 means it's a hydrogen, and a hydrogen has 1 proton, first shell, 1 electron. Okay, so here's my hydrogen, and here's the electron from the hydrogen. Okay, this was the electron from the oxygen. All right, here's my electron from the oxygen, here's my electron from the hydrogen. All right, so that's my Bohr model representation. This is one thing that you'll give me. Okay, another thing that you'll give me is the Lewis structures. We first started looking at these, I think it was last week or the week before, where we did electron dot notation. And in this one, we'll have like oxygen, where we sketched the you showed dots around it was representing the 4 areas. And when they did this, they knew nothing about different orbitals. Okay, there wasn't a name for S, PX, PY, PZ, but that's kind of what these 4 areas represent. So in oxygen, the 6 electrons in the outer shell, that would be 2 in the 2s2, 2px2, py1, pz1, and they found that the hydrogen likes to bond to 2 things, and we learned it early on. Oh, we can get a stable octet, and it likes that. That's another way of saying it. Okay, but we'll put the 2 hydrogens around it. Notice they're angled still, and so this will be the Lewis structure of H2O. And the last thing, that the new thing, the overlapping electron configurations. Okay, we'll do 3 slides, pretty much 3 examples of this. That I'm going to turn you loose onto your OneNote stuff. Okay, so this is the new part. The overlapping part is new. This should be review. Okay, even though it's difficult stuff, this should still be review, and this overlapping part is the new. So we have H2O. I want to show overlapping electron configurations. Electron configurations can show me exactly where the electrons are. Okay, and Bohr model didn't know about them. Lewis structures didn't know about these. So electron configurations should be our most specific ones. Okay, we'll do the oxygen first, and just the valence shell of it. So 1s2, these 2 electrons in the first shell here, don't need those. All the bonding is going on in the valence shell, right? So that's what we need. Okay, so on the 1s2, and then 6 electrons, 2s2, 2px2, a 2py1, and a 2pz1. All right, where I had 2 unpaired orbitals. Okay, and here's what we're going to do. So the hydrogen, as we saw, the hydrogen is 1 proton, 1 electron on the first shell. Boy, it wants 1 more, and we'll do that right here. We're going to put this the language for it, electron configuration language, is 1s1. That's a hydrogen. And look, when we put a box around it to show that from this orbital, this is where they are sharing electrons. Oxygen is going to share it from the 2py. Hydrogen is going to share it from its 1s1. And we have a second hydrogen in the act also. That's the H2O. Okay, a second hydrogen. It's going to share right here with the unpaired orbital of oxygen with its 2pz. Hydrogen is a 1s1. Let's put a box around that orbital where they are sharing 2 electrons from 2 different atoms. That's where they are strongly bonded right there. So the electron configuration can tell us exactly where the electrons are being shared, gained, or lost. That's the power of this. So this is the third thing that you're going to be showing me. Okay, remember, I'll give you the chemical formula, I'll give you the structural formula, you give me the Bohr model arrangement, the Lewis structure arrangement, and the overlapping electron configurations. We got a couple more examples to do. So let's go to the next one. Let's do F2, diatomic fluorine, okay? And this is its chemical formula, that's it. And its structural formula isn't that much more complicated. It's a linear compound, fluorine bonded onto fluorine. Okay, you're going to give me its Bohr model, which is, first of all, a fluorine, 9 protons, 10 neutrons, 2 shells, 2 on the first. And it's going to be in tall column 7. And the electrons don't like each other, so we're going to spread them out 4, 5, 6, 7. All right. Let's overlap it with this one. 9 protons, 10 neutrons. I could have made this a little bit neater, but I'm not real neat with this stuff. 2 electrons on the first shell, 7 on the second. Here's the one. Let's make this the one from the fluorine. There's one of them. 2, 3, 4, 5, 6, 7, and it's sharing this one from this fluorine atom over here. Okay, so they both think they have 8. Very strong bond as these electrons are being shared. It takes a lot of energy to rip these apart. These are in structures in U. Notice, and it's a valence shell. The valence shell of each is in the act. The inner shell or the kernel shell electrons aren't involved at all. All right. So you're going to show me the Bohr model. The Lewis structure isn't real complicated. Now remember, they came up with this, like I said, before they knew about electron configurations. Okay. So here's the 4 pairs. Here's my 7 electrons and another fluorine. Here's its, let's make that, well, that can be like it's 2s, 2px, 2py, and a 2pz1. Oh, well, that's okay, because it's sharing right here with this 1 electron from the other fluorine. Here's my Lewis structure of it, where you showed me the valence electrons, you showed me 8 of those, and what's being shared is in between them. Pretty cool. Okay, now, overlapping electron configurations, the new part. Since it's fluorine bonded to fluorine, they're going to overlap. Let's just put them right next to each other. It's going to work. 1s2, forget it. I need a 2s2, 2px2, a 2py2, and a 2pz2. Okay, I'm sorry, a 2pz1, 2pz1. And same thing down here, a 1s2, a 2s2, a 2px2, I forgot my 2 up here, a 2py2, and a 2pz1. These are filled, not filled. These are unpaired. This is where they're going to share. They're sharing from the 2pz. Where are the electrons being shared in fluorine? From their 2pz's. Okay, so that's a third thing that you're going to give me. Let's do one more example that I've come across, and that is what you're breathing in right now, molecular oxygen. Okay, that's its chemical formula. Its structural formula is it's double bonded. And before I said there wasn't a great way of showing this in Bohr models. I saw one just the other day, and it was pretty simple. Wasn't much variation, so we're going with that. So the Bohr model representation, you have to give me each oxygen 8 protons, 8 neutrons, 2 shells, 2 on the first, 6 electrons on the second. Actually, don't we're not going to put those yet. Let's put form around there right now. Okay, I'll show you how we're going to do this. Of course, we're going to overlap them. All right. 8 here's my other one. 8 protons, 8 neutrons, 2 electrons on the first shell. Let's put 4 out. 2, 3, 4. And you can see where this is double bonded, okay? And 2 electrons in each bond, okay? So I'm going to need a total of 4 electrons in it, 2 in here, 2 in here, okay? And here's how they do it. Let's say this electron is from this one over here. This electron is from here. To show a double bond, I just stick more of them in here where they're all overlapping. That seemed to be a simple way to show that. Showing a complicated thing that's three-dimensional, flipping around all over the place with the double bonds and putting it in two-dimensional shape on the board isn't all that easy. But that seems to be a neat way to do it. If I see 4 electrons in here, I know 2 bonds. Okay, 2 electrons per bond. All right, my Lewis structure, I had oxygen and oxygen. Actually, I need a little bit more room in here because I got a double bond, don't I? So double bond is how many electrons? Double bond is 4 electrons, 2 per bond. So I've got one sharing from this oxygen, one sharing from the other oxygen, one sharing from this oxygen, 1 electron from the other oxygen. Okay. So here's 2. I need 6 more. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. All right. There's my Lewis structure. My overlapping configuration of oxygen. Each oxygen is a 1s2. I don't need it. I need the second shell. It's a 2s2, a 2px2, a 2py1, and a 2pz1. Oxygen's going to gain in its 2py and its 2pz. My other oxygen, let's line them up. 1s2, 2s2, 2px2, that's all good and safe. 2py1 is unpaired, 2pz1 is unpaired. Oh, look, here's my double bond. Oxygen is going to share at the 2py's, and it's going to share with each other at the 2pz's. They both have 2 electrons now, and that's what you're going to show on this. Okay, so there's my 3 things. I'm going to turn you loose now, and you can get on OneNote and practice some of these things. You can always refer back to this as you need to. Thank you.